Hello, this is a question for Sadi Baudelaire, and it is, let me try and look, it is May, June. Where are we? 2021 is the year, and it's paper 22. And it's 1E. Now, look at it. It doesn't look like much, does it? Compound Y is a pure insoluble salt solid, which contains halide ions. A single reagent is added directly to Y to determine the halide ion present. Identify the reagent, and what would you see? Now, believe it or not, there's a lot in this question, and I don't know whether you're totally familiar with all this stuff. This is group 7. Okay, and the part of group 7 is how halide ions react with sulfuric acid. Now, whether you like it or not, you got to learn this. Okay, so let's have a look at the halide ions, shall we? We ignore fluorine, so let's start off with chlorine. What's after chlorine? Bromine and iodine. Now, when these guys react, they gain 2 electrons. Okay, and they form the halide. Okay, which is what we're interested in. Minus, minus, 2I minus. So, obviously, on the left, these guys are called halogens. Oops. Halogens. And these guys on the right are called halides. Okay, now this is what you've got to know. All right, which one of these reactions is the most, wants to go to the right more? Well, it's obviously chlorine because it's the most reactive. So the chlorine is most reactive, and iodine is the least reactive. Okay, first of all, we've got to know that. All right, now when chlorine reacts, it steals electrons from things. There they are. When bromine reacts, it steals electrons from things. And when iodine reacts, it steals electrons from things. But chlorine does it the best. And if I steal your electrons, I'm an oxidizing agent. So this is the best. Chlorine is the best oxidizing agent. Okay, and then you go. The worst one, the worst is iodine. All right, this is not the worst ever, but it's the worst in these three. Now, so on the left we have halogens, and halogens are, let's get a nice color here. Halogens are oxidizing agents. All right, so there you go. That's the first thing. So it's the best is chlorine, and the worst is iodine. However, if we look at the halide ions, where we think of going backwards this way, and this way. And in this case, the halide is turning back into the halogen and is giving up electrons. It's giving you electrons. So these guys on the right-hand side, these are reducing agents. Okay. Now, which one wants to go from this side? What side is this? From right to left. We've already determined from left to right it's chlorine, but what wants to go from right to left the most? Well, if chlorine wants to go this way, loads, it's going to want to go backwards a little bit. And if iodine only goes this way a little bit, it will want to go that way a load. So believe it or not, out of these three, the best reducing agent is the iodide. This is the best reducing agent of these. And this is the worst. Now, what happens to a reducing agent? A reducing agent, when it does its job, it gets oxidized. Okay, that's what happens to reducing agents. They get oxidized when they do their job. So if this one is the best reducing agent, it must be the most easily oxidized. And this is the worst reducing agent, so this is hard to oxidize. This is how I remember it. My inorganic chemistry is awful, really. But I remember like little things like this because they come up so often. So that's what I remember. Okay. Now, so I hope that makes sense. Whoops, daisy. So remember all of that rubbish. Okay, and then I've got a clip to show you. I think I do anyway. I just took one a minute ago. Here it is. Okay, there it is. You can't see this. I don't think you can anyway. All right, put that in there. There you go. And that's 92%. All right. Now, these are reactions of concentrated sulfuric acid with the halide ions. Okay, as you can see. Now, let's have a look at the first one. Well, the first one starts off with chloride, and it ends up with chloride. So the first one is not a redox reaction. Okay, now concentrated sulfuric acid is a very powerful oxidizing agent. Okay, and it's not good enough to oxidize chloride, because if you remember, chloride ions are hard to oxidize because they're most easy. What am I trying to say here? The halogen is easy to reduce, but the halide is hard to oxidize. All right, so we can't oxidize a chloride ion, and that's why the first one we get HCl. All right, and this is why we can make HCl. All right, now the bromide here, it goes to bromide -1 here. So no, this bit is not a redox. Not a redox. But then the HBr here, which is -1 oxidation number, goes to 0. Okay, and the reason that the bromide ion here is oxidized from -1 to 0 is because bromide ion is easier to oxidize than chloride. And so you get bromine. And bromine is a brown, because everything heats up here, you'll get a brown vapor. Now, if we did exactly the same iodine, -1 here, -1 here, this part is not a redox. All right. But then -1 here goes to 0 here. And not only -1, look at that, 8 of them do. So iodine is easier to oxidize than bromide even. Okay, because 8 of them, you're oxidizing 8 of them. Here, where are we? Here, 1 sulfuric acid can oxidize 2, but here, 1 sulfuric acid oxidizes 8. So it's easier to oxidize iodine. Okay, so a good test if you have a solid halide, a good test is to add conc sulfuric acid. If it's a halogen, sorry, what was I saying? Sorry, if it's a chloride, we get a colorless. Actually, we won't get that, will we? We'll get white fumes if it's a chloride. If it's a bromide, you'll get a brown vapor. And if it's a, what's this one? If it's an iodide, you'll get a purple vapor, because things get hot. Okay, so I hope that makes sense. But as I say, it's a good question, but there's a lot to unpack here. So let's have a look at this. Compound Y is a pure substance. Single reagent is added directly. So the reagent is going to be conc, not normal sulfuric acid. It must be concentrated sulfuric acid, or H2SO4 liquid. All right. Now it says what would happen with bromide. Well, you would get brown fumes. Okay. I hope that makes sense. If it doesn't, give me a shout and I'll update it.